Hey everyone, and welcome to This Explainer. We're diving into a topic today that is fundamentally rewiring how we build technology. Look, if you're building digital products right now, you are absolutely feeling that massive pressure to ship AI features, right? It's everywhere. But there's this hidden world behind every successful AI product, a world that separates those really magical, flashy demos from the robust, enterprise-grade tools we actually rely on every day. So today, we are going to explore the complete theory and application of AI evaluation frameworks, specifically tailored for product managers. We're going to demystify exactly how you can systematically ensure your AI is safe, reliable, and, genuinely helpful. To really ground us, let's start with this thought from Chief Product Officer Mark Krieger. It just hits the nail on the head regarding the core conflict in AI product development right now. In traditional software, if a feature works in a demo, well, it's probably going to work for the user. But AI is probabilistic. Shipping a generative AI feature based purely on your gut feeling or, a couple of successful test prompts is a massive risk. You are literally rolling the dice. It might look fantastic on a pitch deck, but relying on intuition when outputs can change every single time a user hits enter, yeah, that's a recipe for disaster in a live production environment. Which brings us to the most urgent, high-stakes question facing literally any product team today. When there is no single correct answer and the whole system is designed to generate completely novel responses right on the fly, how do we know if it's actually working? How do we measure success when there is no strict ground truth to point to? Okay, let's dive into our roadmap for this explainer. First, we'll cover the AI evaluation imperative. Second, moving beyond basic accuracy. Third, metrics that drive user trust. Fourth, building your evaluation suite. And finally, fifth, scaling evals with tooling. Section 1, the AI evaluation imperative, shifting from demos to discipline. We are completely moving away from the era of just going by vibes and entering an era of rigorous product quality standards for AI. And to understand why this shift is mandatory, we really have to look at the fundamental difference in the software itself. Think about traditional deterministic software. It relies on unit tests, integration tests. It has incredibly well-defined pass or fail criteria. If you put X in, you get Y out, every single time. But probabilistic AI systems, they are entirely different wild beasts. They give you open-ended outputs, you got the potential for hallucinations and context drift. The exact same input can yield a completely different result on Tuesday than it did on Monday. Because we don't have a traditional compiler to catch a bad text output, launching without a completely new kind of safety net means we are quite literally shipping in the dark. Enter AI evaluations, or just evals for short. Think of evals as your brand new, completely mandatory safety net. They're structured tests designed to continuously measure how well your AI model is actually performing. If you're a product manager, evals are essentially your product QA, your UX testing, and your data science validation, all seamlessly rolled into one ongoing process. They beautifully balance complex data science metrics with real human judgment and business outcomes. Section 2, moving beyond basic accuracy, the accuracy versus trust dichotomy. Now, what's really interesting here is the stark distinction between lab performance and real-world reliability. We really need to reconsider what success actually means. On the technical side, sure, you've got accuracy as a baseline, but you also have your F1 score, which measures that tricky balance between precision and recall, log loss, which heavily penalizes a model for being confidently wrong, and ROC-AUC, testing how well the model separates distinct categories. And look, these are absolutely vital starting points, but they aren't the finish line. Over on the product side, we have the trust metrics, things like hallucination rate, latency, bias, and robustness. Ultimately, these are the metrics that determine if an everyday user will actually adopt and rely on your product. So, the absolute crucial takeaway here is this. Accuracy measures correctness, but trust measures reliability. You could have a model that scores 95% on accuracy in a nice, pristine lab environment, but if it takes 10 seconds to load, occasionally outputs heavily biased language, or just hallucinates facts when asked a slightly complex question, your users are going to abandon it immediately. There's no way around it. Users only stick around when they get both absolute correctness and rock-solid reliability. Section 3, metrics that drive user trust, measuring what actually matters. Let's actually dig into this specific taxonomy of trust metrics. First up, the big one, hallucination rate. This is the percentage of outputs that contain unverifiable, fabricated, or just completely false information that directly contradicts your source material. Let's say your customer service AI confidently invents a fake refund policy and promises a user their money back. Well, that user's trust is instantly, permanently shattered. Here's a really hard truth for AI PMs. Users do not forgive confident mistakes. Tracking and minimizing factuality errors is absolutely vital to survival. Now, measuring this can be a headache, but one incredibly efficient method is using a trustworthiness filter. Basically, you use an automated checker model to rigorously review just the riskiest 20% of responses. By doing that, teams can catch nearly all incorrect outputs. That leaves under 1% of errors in the remaining 80% of responses, which are just auto-approved. It's an incredibly smart, leveraged way to scale hallucination detection without needing a human to manually read every single output. Next up, bias and fairness. These metrics are all about ensuring your AI plays fair across all demographics. You're actively checking for something called disparate impact, meaning you really want to know if your model systematically underperforms or behaves inappropriately for very specific groups of users. To see the devastating real-world consequences of ignoring this, let's just look at the Apple Card controversy. So the overall AI credit model they used actually had highly rated accuracy across the board. However, when it was deployed, it was discovered that the model was assigning significantly lower credit limits to women. And this was happening even when they had financial profiles nearly identical to their male counterparts. So the model was technically accurate on average, but deeply unfair in practice. This impartially but clearly highlights exactly why demographic slice testing, which is evaluating your model separately on specific subsets of data, is completely non-negotiable for PMs. Another massive piece of the puzzle is UX trust and consistency. This measures whether an AI model behaves in a predictable, stable, and clear manner. A model can be 100% factually accurate, but if it presents the answer in a confusing format, or if it answers the exact same question in two wildly different tones on different days, the user experience completely breaks down. Remember, trust is built on predictability. Think about something we use every single day, like Gmail's Smart Reply. Those 3 little suggestion bubbles seem so simple, but the evaluation running behind them is intense. The AI has to be tested, often using human annotators or automated LLM as a judge workflows, just to ensure the suggestions are genuinely helpful for the UI. It has to evaluate if the tone actually matches the user's typical communication style, and it has to ensure the length makes contextual sense for a quick tap. It just goes to show that even the simplest looking AI requires a highly complex evaluation of its UX fit to maintain our trust. And rounding out our trust metrics, we have the Population Stability Index, or PSI. Look, even the absolute best models decay over time, purely because user behavior and language are constantly evolving. PSI measures how your live input data distribution is shifting compared to what your model was trained on. A PSI rising above zero point 0.2? That is your ultimate early warning sign of model drift. It's a flare going up telling you your live data no longer looks like the training data and signaling that it's time to retrain before the user experience starts to degrade. Section 4, building your evaluation suite, taking this from theory to operational discipline. So how do we actually structure all these tests in the real world? Well, a robust evaluation framework requires 3 mandatory layers. First up, golden sets. Think of this as a spreadsheet of 500 perfectly human-labeled Q&A pairs. You use this as an unchangeable benchmark to test baseline correctness every single time you update the model. Second, adversarial sets. These are your red team prompts. They're intentional edge cases and jailbreak attempts designed specifically to trick the AI into failing, so you can test safety and bias under pressure. And third, dynamic live sampling. This involves continually scoring just a tiny, anonymized slice of real production traffic. That's how you catch that ongoing model drift we were just talking about. Section 5, scaling evals with tooling, empowering the entire product team. To operationalize a suite this complex, you really can't rely on manual spreadsheets anymore. The evaluation tooling landscape has absolutely exploded, giving us specialized platforms for all sorts of different needs. For instance, DeepEval provides incredibly deep open-source metric coverage. If you're building retrieval augmented generation, Ragus is heavily focused on evaluating those specific pipelines. Moving up to scale, Arise AI is fantastic for enterprise-level machine learning monitoring. LangSmith offers native tracing if your team happens to be deeply embedded in the LangChain ecosystem, and platforms like Confident AI are doing great work pioneering cross-functional collaboration, tying those production pipelines directly back to your metrics. And honestly, that cross-functional aspect, it is absolutely vital. AI quality is a team sport. If every single time a product manager or a QA tester wants to run an evaluation on a new prompt, they have to submit a ticket and wait a week for an engineer to write a script, your development cycle is going to grind to a complete halt. Modern tooling makes it possible for non-engineers to run these sophisticated evals independently. It empowers PMs to take direct control, making AI quality accessible to the domain experts who actually understand the user's needs the best. Well, we have covered a massive shift in product philosophy today, moving away from the illusion of the perfect demo and stepping up to the rigorous discipline of continuous evaluation. So I'll leave you with this final provocative thought to take into your next product review. Your AI might boast 95% accuracy in the lab, but given everything we've explored today about hallucinations and bias and UX consistency, do your users actually trust it? Thank you so much for joining this explainer, and good luck building AI products that truly earn your users' confidence.